Alright guys, so what we're going to do now that we've learned what a log is we're going to look at some different things we can do with logs. So the first thing we're going to look at is a condensed log versus the expanded log. So what I have over here on the left are three different versions of a log condensed, with the argument condensed. Remember, the argument is what's inside the parentheses there. So if I want, I can take all of these condensed logs and rewrite them in an expanded version. The first one of those, if I have the log of a times b, so the argument is being multiplied, I can rewrite that as two separate logs being added together. And if you think about your exponent rules, this makes sense. If I have two exponents, like x to the x squared times x to the third, I added those two exponents together. So it's a very similar type rule. Okay, again, another similar type rule. If I divide, I can actually rewrite this as subtraction. Now, what you have to be careful of here, though, is that I'm dividing the argument, which is what I'm taking the log of. That's the only part that's being divided. What I do not have written here is I do not have the log of A divided by the log of B. That's not the same thing. Okay, so I couldn't rewrite that as subtraction. It's only when it's the argument that's being divided. And then the last one I have is I have the argument raised to a power. I can take that power and move it to the front and multiply it. And again, that makes sense, right? If I have x squared raised to the third power, I multiply those exponents. That's x to the sixth. So just like that, I'm going to be multiplying this. So this becomes b times the log of a. And now it looks like bloga, but remember, that's multiplication here. Okay, so you move your exponent to the front and multiply it. So what we're going to do now is we're just going to do a couple examples, one where we're going to condense a log and one where we're going to expand a log. So we're going to start by condensing. Now, one thing to look at when you condense is you can only condense logs that have the same base. So all of these logs have a base of 3, so it's okay to go ahead and combine these into one. So my final goal here is to have the word log written once. And you can show it in multiple steps if you need to. I'm going to go ahead and take a couple steps just so you guys can see a little bit of the process here. So the first thing I have is this 1/2 out in the front. So the 1/2 in the front, if you look back at your rules, is the same thing as the exponent on the argument. So I can rewrite that term now as 7 to the 1/2 power. And another way we could write 7 to the 1/2 power is the square root of 7. Now again, going back to my exponent rules, if I have two logs that are added together, I can rewrite those as the argument being multiplied. And then finally, I have two logs that are subtracted, so I can write this as one final log, and I can divide my arguments. So now I have what I wanted, which is one log of my final answer. And I actually can divide this a little bit farther, and I can just rewrite this, because 12 divided by 2 is 6. This can just be 6 square root of 7. Alright, so now if we're going the opposite way, if I'm trying to rewrite a log as multiple logs, I'm going to expand this. Okay, so I'm going to start with the top of my fraction. Okay, what I'm going to do is I'm going to split up this top from the bottom. So what that means is if I have the natural log of the top, in order to rewrite the argument with division, I have to subtract. And now I can work to simplify each of those little parts. So I'm going to work with this first log. If I have a argument that's multiplied, I can rewrite that as the natural log of A plus the natural log of B. Then if I look at my middle term, this one's a little bit tougher, because if you look in this term, I have this D plus 1 here, and I have the cube root of C. Those two parts of the argument are multiplied together. So what I'm going to do is I'm going to leave this subtraction sign and put some parentheses since I'm subtracting both of them. And I'm going to separate these by adding those two terms together. Now what I need to be careful of here is, first of all, I have to remember those parentheses, because those are both at the bottom of my fraction. What I also have to be careful about is this D plus 1 here. I actually can't simplify that D plus 1 anymore. with my rules. I can't make that the natural log of d plus the natural log of 1. It's not the same thing. Okay? The only other thing I can simplify here is this cube root of c. And I can rewrite that as c to the 1/3 power and move that 1/3 to the front. So what that's going to do to my final answer is that's going to make me have the natural log of a plus the natural log of b minus 1/3 the natural log of c plus the natural log of d plus 1. And that's my final expanded version. So I have multiple logs, and none of them have any multiplication or division or anything else in their argument. So the last thing we're going to look at with logs is something called the change of base formula. Now the change of base formula was very, very important with our old calculators, because your calculator, if you type in a log in your calculator, it's automatically going to give you a log of base 10. So if I were to type in any number, it's automatically going to assume that 10 is right there. The only way I could type in a different base in my calculator is to use this change of base formula. So this change of base formula is really simple. What I can do is I can rewrite this as a log of any base of x over a log of, again, any base but that same one over that base, and that's going to be equivalent. Okay, so what that means for me is that log base 2 of 5, if I wanted to type that in my calculator, I would have to type that in as log of 5 over the log of 2. And remember, it could be a log of any base, which means I also could make that a natural log, because the base that I use doesn't matter. Same thing down here. This could be the natural log of 5 over the natural log of 2. Now with your new calculators, you guys will notice it actually will let you write a different exponent base in there, but it's still nice to have this formula just because it'll help you with some substitution stuff maybe later on.